Good afternoon, everybody. My name is Michael Stones. I'm the PowerINSPECT product marketeer, and I'm sat here with Kieran Gill, a PowerINSPECT Applications Engineer, and we're going to give you a presentation today talking about the latest features and functionality, the tips and tricks in PowerINSPECT 2015 R2, the latest release of the software. Just to kick off with a brief agenda for today's presentation. So we'll begin with a quick news update. So there are a few things that I want to tell you from our side, what we're working on, and some of the changes that are coming in terms of Delcam's maintenance. And then Kieran's going to get on with things and look at the main content for today's presentation, the new features. Then at the end we'll both be available for any questions and answers. So if you do have any questions, please wait until the end, and then we'll do our best to answer them then. Okay, so here we go. Just to begin with some news from the Delcam side. You can see two tablet apps there on your screen which feature our learning zone. I hope that you're all aware of the Delcam iPad app. This is something that's new to Delcam in 2015, and it allows you to conveniently view all of the Learning Zone videos on your Apple tablet device. Now this is great because you can see the videos which document the latest functionality, the latest enhancements in not only PowerINSPECT but also in PowerMill, PowerShape, FeatureCam, PartMaker, Crispin, any of Delcam's software. And you can view that on your Apple tablet device both online or offline. So for example, if you wanted to download some new functionality videos and then take them with you into the workshop, then you can view them via the Learning Zone app. You can find out more information about that on the Delcam website or of course in the Apple Store. So the second thing that I want to talk to you about is the PowerINSPECT webinars. Now of course you're here with us today and we're talking about the latest tips and tricks in PowerINSPECT 2015 R2. But this isn't the only webinar that we're doing. We're hoping to host 8 to 10 webinars throughout the year to tell you some of the tips and tricks, how to make the most of our software, and also for some industry discussion and analysis. So earlier in July I hosted a webinar with a friend from Coventry University who talked to us about how to minimize the variation in your measurement. And all of that content is available via our website at powerinspect.com/webinars. Now this is really a topic that I've pioneered, so if you do have any suggestions for topics that you'd like us to discuss, then please do get in touch with me. My email address will be on the screen at the end of today's presentation. Okay, so the final news item for today before I pass it over to Kieran is to do with some changes that are coming to Delcam's maintenance terms. This is something that everybody should be aware of, and it is something that is going to affect the future maintenance contracts. So I'd encourage you all to refer to delcam.com/maintenance where you can find out more information about how these changes might affect you. Okay, so on to the main topic for today, the tips and tricks. Now I'll pass it over to Kieran, who's going to talk to you about some of the time-saving enhancements in PowerINSPECT 2015 R2.
Right, thank you, Michael. Hi everyone, my name is Kieran Gill. I'm the application engineer here in the PowerINSPECT support team. Today we're going to be having a look at some time-saving enhancements. We're going to have a look at some new features and just basically get a sort of an overview feel for some of the new enhancements and features that are in 2015 R2. Okay, so let's not waste any time. Let's go straight ahead and we'll jump into an improved way of identifying our CAD surfaces. Now in PowerINSPECT 2015 R2, it's now even easier to select and identify surfaces within a CAD model. We're going to navigate to the CAD tree, as you can see on screen. We're going to click on the part name, and PowerINSPECT will select all the surfaces associated with that part. This is also available when using existing CAD levels as well as user-defined levels. Okay, as you can see, we're clicking on our levels and then lastly the user-defined level to select them all. By clicking on the I button in the CAD pane, we are switched between a detailed and a summary view. By entering the detailed view, the relevant individual surfaces can now individually be viewed. By selecting them on the CAD tree, the corresponding item is highlighted in the graphics window. Alternatively, by selecting the surface selector on the right-hand side from the mouse context toolbar, we can simply click on a surface within the graphics window, and this will then highlight the corresponding surface in the CAD tree. It's also very important to note that the surface inspection enhancement that you're seeing also applies to the CAD level for inspection form, which can be found from the Measures tab at the top of the screen. This selection enhancement also applies within the Levels for ProPath verification form, which can also be found above in the Tools menu. Okay, so a couple of nice little enhancements there to the way we identify our CAD surfaces. Let's now move on to our feature extraction from point cloud data. Now essentially, just a couple of pointers before we move into an actual demonstration hereof. And these pointers you should bear in mind as I'm doing the demonstration. And the first one of those is that this is the brand new method we've got for evaluating geometric features from point clouds. We also have an updated point source tab for each individual geometric feature, and this is all point clouds. We can also now, and I think the biggest benefit out of all of this is that we can create an entire sequence tree in advance and then automatically evaluate the scan data. And this is very pertinent, because what you can then do is really speed up and make efficient your batch inspections that you are doing on very similar parts. Okay, so it's very important. So let's jump in and let's go and have a look at this demo and see how it works. So we're going to zoom out and we're going to move to PowerINSPECT. Currently open on screen, I've got 2015 R2. We're going to start up a new job. In this case, I'm going to go ahead straight away and I'm going to import my CAD file. So from the CAD menu, we select the plus icon and we're going to import our CAD file. Just going to make sure that we can position this CAD part in a suitable view direction. Jumping back to the sequence tree, we have now two options in which we can go ahead and evaluate our geometric features. The first one is to select our features from the geometric toolbar on the left-hand side. You can also do this by selecting the wireframe checker on the right-hand side. I'm, in this case, going to opt for my wireframe checker. Now the big brand new feature, as I mentioned earlier, is when selecting a geometric feature, we now have the option from the Geometric Explorer window to select Extracted from Clouds. Okay, so I'm going to green tick that, and I'm going to move along and continue to create my geometric features for the remainder of this part. Right, so once we've got those, we're going to turn on our labels just to show that we have none of these items evaluated yet. I'm quite happy with that. We're going to jump up back to our definition level and we're going to go ahead and create a CAD view report. Now it's very important at this point that the user would actually jump in and go and scan the item live. But because we want to save you guys some time, we actually did the scanning earlier, and just want to show you a little video of how that scanning is actually done, so you get a good idea of what the data is going to look like when we bring that data in. Okay, so we're just going to double click on this video, and there you can see us taking points with the scanner. It's important to know in this scenario that the user must make sure they can scan all of the relevant geometric items necessary to gain that feature recognition from the points relative to that individual geometric item that is being scanned. Okay, so it's very important to get all of the data around those individual geometric items so we can evaluate that. Okay, so we're just going to jump out of that, and we're going to go ahead and bring in that exact same scan data that we've just scanned. Okay, we'll just wait for that to load in. Right, once that's loaded in, we can go ahead and project our point cloud onto our CAD model. And there we can see a projection. Now, let's just jump up one level and we can see now all of our features that we've asked to be specified have been highlighted or have been now evaluated. You should now be able to go and generate a report. So if we go and have a look at that report for just a second, we can clearly see how all of these items have been evaluated, and we can inspect them visually on this table in greater detail. You may also say, looking back at the CAD view, that we've got some areas of unprojected points. By simply clicking on the Filter tab, we can go ahead and uncheck the displayed projected points. Once we've done that, you'll see they are removed and we can close our item. Okay, so that is nice and simple and straightforward, which shows the evaluation of geometric features by means of evaluating them from the point cloud data set. Okay, so let's move on. Let's go back to our presentation for just a second, and we'll move on to some of the brand new features for 2015 R2. CNC Racks is something we're very excited about in 2015 R2. The CNC Racks area has been added to the Machine tab, and this then currently enables you to manage the MCR20 and FCR25 racks during any given inspection. Currently, I've chosen the MCR20 rack, as you can see on screen, and we now need to mount the rack onto the measuring device and then align that with one of the major axes, as you can see. We then need to locate the rack so that PowerINSPECT knows where the rack is within the measurement volume area of the CMM. PowerINSPECT will guide us to locate the rack by taking 3 points on top, 2 points along the aligned axes, and 2 points within port number 1 of the rack. Okay, so we can see us taking those individual points and PowerINSPECT guiding us through this. Now essentially what we're doing is the 3 points on top give us a plane, the 2 points give us a line, and the 2 points inside the port 1 give us a point, and essentially we're doing a PLP alignment. Okay, we now have located the rack, and we can now use the CMM to perform a full CNC probe tool change. What you're seeing on screen is the CMM will actually move over to the rack, drop the first probe off into the port, and then move over to collect the new tool to continue the probing sequence. Okay, so drop that probe off and then moving down and picking up the new probe. Once it's done that, it'll move off back to the safe distance and continue probing or inspecting the part. Okay, so that's very exciting. Now let's dig a little bit deeper into that and let's talk about sub-assemblies, how we go about building this all up. Okay, so this is once again a very exciting aspect. The Machine tab has also been extended, as in CNC Racks, to include the machine tool probe sub-assemblies. Here on screen we've created a static sub-assembly, what we call a static sub-assembly, and I'll talk about this in just a minute. But we've created this for a Pantech head. First I'm going to select the extension for the probe body as seen on the screen. Next I need to create a sub-assembly for the probe module. To do this I select the correct module alongside any other extension, as well as selecting the appropriate styli for the sub-assembly. Okay, now you'll also notice that during this build-up phase that the items being built up started at an initial mounting point, and that's what I refer to as a static sub-assembly. Okay, the probe tool naming convention is paramount. But it's always given flexibility by being determined by the user. Now, you should also note that to eliminate confusion when you're building these sub-assemblies up, is that you should give it a naming convention which includes possible names like the module type, the styli length, and probe diameter, which are all very useful for aiding identification. The sub-assemblies can now be viewed in the Machine tab preview and expanded to show what parts they are made from. We now need to move over and create our probe tool by selecting New from the Probe Tool tab. We will then name the probe tool something suitable, as I've suggested in the previous message, and then we'll select our created sub-assemblies that were created. We select our static sub-assembly, and then we select any of the sub-assemblies we have already created. And by doing so, we can continue to create as many probe tools as we need. We finally need to assign our sub-assemblies to a suitable rack. So from the CNC Rocks tab, which you'll see in just a minute, we're going to want to edit the position in which our sub-assemblies are positioned. Okay, so highlighting on the screen, we're moving towards our CNC Rack tab. We open that up, and we can now position one of our sub-assemblies in a suitable port location. Okay, you can see on screen I'm going to be picking my 6x30 and positioning that in port number 3, and so forth. I can go ahead, continue to further specify where my other sub-assemblies need to be positioned. Once all of the assigned sub-assemblies have been located, the probe can be selected in the tree, and we can now perform a full CNC probe tool change using the rack. Okay, so once again, the Pantech head moves over, drops the sub-assembly into position, and then picks up the sub-assembly we've asked to have placed in rack position number 1, and then continues its probing sequence. Right, so let's move on to now CAD-level collision checking. It's now possible to exclude surfaces from collision checking. Let's first create an inspection sequence. We'll do this by using inspection on the fly points, and we will create an inspection point along our model. As you can see, I've placed 2 down, and then I want to inspect the blue part of this model. But as you can see, we can now clearly see that we have a collision on the CAD as well as on the probe, which is situated between point 2 and point 3 of the intermediary probe path. We can see the brown stars indicating a collision on the CAD model as well as a collision in the sequence tree. You can see that the running the simulation highlights this collision. In this particular model, the orange areas have actually already been machined in an earlier manufacturing process and thus don't really exist. So to exclude them from the collision checking, we need to click on the CAD tab and then click on the green star to change it into a red star. This means that this particular surface item has now been excluded for collision checking. You should also now note that the change to the entire CAD group icon has now changed from a green star to that of a green star with a red border, so as to illustrate a combination of included and excluded items for the collision checking. As shown on screen, we can also change collision checking for individual levels by clicking on Tools and Levels for probe path verification. Okay, so you can clearly see the benefits there of being able to toggle off individual levels for collision checking. Okay, so at this point, I'm actually now going to hand over back to Michael to further talk to you about some brand new features as well. So Mike, over to you.
Okay, thank you, Kieran. Right, so we should now be looking, yep, we've got the slide up. So we're looking at a new feature that we've added to 2015 R2 to do surface waviness. But what exactly does that mean, and why do we want to report on surface waviness? So we all know that irregularities might arise as part of the machining process. In the webinar that I did earlier in the year with Ian Wilcox from Coventry University, in that we particularly talked about 4 areas where variation might arise in measurement or in the manufacturing process. Some of these surface irregularities might arise as part of the manufacturing process as a result of tool wear or worn machine tool components. And one of the benefits of this new functionality, which allows you to report on surface waviness, is that you can include extra detail as part of your report. But how do we do this? So in PowerINSPECT, you can go to the Measures, Parameters and Inspection Point tab, as you can see on my second bullet point there on the slide, and you can select the tick box to calculate waviness. And what actually happens, so each surface inspection point has a tolerance, of course, and also there's a width value, and that is to say it's the kind of search proximity criteria around that point. And what you need to do in PowerINSPECT is to set that width value, the area around which you want to search, and for each point, and you specify what the acceptable deviation is. Now, if the deviation is less than or equal to that maximum deviation that you specified in the inspection tab, bullet point 2, then the part will pass. Okay, so moving on to the second feature that I'm going to look at here at the end of the presentation is geometric items. Now, in this instance, there have been some additions to the way that PowerINSPECT works with geometric items. First of all, we now allow you to specify the fitting method for probe planes, lines, and compound lines. Now, previously, what happened in PowerINSPECT is that planes, lines, and compound lines were all fitted by the least squared method. And this is very good for a general purpose interpretation of the measurement results, but it doesn't describe what happens in reality when the feature needs to fit against something else. So now you also have the maximum material condition and the minimum material condition as 2 alternative fitting methods. So we can see there on the video that the pink line at the bottom is slightly inside the CAD model. So let's just explain a little bit about maximum material condition and minimum material condition. So if we imagine that we've got to fit a part, a perfect plane, and we've got to sit it on top of something else. Imagine a tower on top of a table and you've got to fit another part on top of that. So if we imagine that the part we're sitting on top of the tower has a perfect plane, and if we were to use the least squared method that was previously in PowerINSPECT, then what we would do for the tower, the part that we're trying to fit onto, is we'd take the average across all the points on the top. So if certain points were higher and certain points were lower, perhaps for example a point in the middle might be slightly higher than a point on the outside, then actually we try and fit that, but it wouldn't quite work. When in reality, in this instance, when you're fitting something on top of something else, then you need to use the maximum material condition. And we now allow that fitting method in PowerINSPECT. So the maximum material condition is represented by the 3 highest points. Okay, we can see now on the video on the screen that there are some numbers flashing around and we're highlighting different areas. This brings me to the second part of the new geometric items feature that I want to talk to you about today. and that is to do with the GD and T surface profile calculation. In PowerINSPECT 2015 R2, we allow you to set a per item proximity criteria for all GD and T profile items. So the surface profile, the GD and T surface profile, is controlled by a proximity criteria, as is a surface inspection. But one of the things is that because the GD and T surface profile can use a different datum scheme, it's useful for us to allow you to have greater control over the proximity criteria. Now this geometry items, this GD and T surface profile enhancement isn't a sole addition in 2015 R2. It also complements some of the additions that we've made recently in the software, so a series of enhancements which give you more control and visibility over the proximity criteria and allows you to control the number of points which are used in your GD and T surface profile calculation. Okay, so the final feature that we're going to look at today is that of temperature compensation. Those of you who were with us back in 2014 will have seen that in PowerINSPECT 2014 we also had a new feature that concerned temperature compensation. And what's better, those of you who were with me earlier in the summer when I was with Ian Wilcox, he talked about how temperature can influence our measurement results. So previously in 2014 we allowed you to work with devices which had an integrated temperature sensor, so for example the newer Roma arms, and now we've extended that feature even more and we allow you to specify the temperature of a part immediately before inspection. Okay, but what does that actually mean? Why is it important to specify the temperature of a part immediately before inspections? Or where might that be beneficial? So it's particularly useful for batch measurements of items. For example, in the video, what Kieran did for me earlier in the day was he measured a component. He's come into the factory and he measured a component in the morning, took the temperature and said, okay, I'm measuring this component at 1 degree Celsius. It was a very cold morning. So PowerINSPECT allows you to input this information. It asks you what material the component is that you're inspecting. It uses the thermal coefficient of expansion to say what that value would be at the recommended inspection temperature. So again, if we reference that presentation that I did earlier in the summer, we said that all parts should be inspected at 20 degrees Celsius. So we measure something in the morning and it's 1 degree, it will tell us what that measurement would be, taking account of the fact that it's cold and the part is contracted. So we said this is useful for batch measurement. Kieran then comes back to the factory after lunch, and as you can see in the video, the temperature has risen starkly and it's 65 degrees, a very hot afternoon. And this has real life applications, so you might come back later in the afternoon, the sun's been shining through the window and it's much warmer. Now what PowerINSPECT will do is it will automatically prompt you to input what that temperature is. So you might put it in at 65 degrees and PowerINSPECT knows that at warmer temperatures those parts expand, and we use that information to compensate the results so that you should then have a consistent and repeatable set of measurements from the start of the batch to the end of the batch. Okay, so that brings me to the end of the new features that we're going to look at in this brief presentation today, and I'd just like to tell you where you can find some more information before we get on to look at the questions. So you should all be aware of the PowerINSPECT learning zones, lz.powerinspect.com, where you can see all of the new features that are added to PowerINSPECT with each release. So this time round you can see all of the 2015 features, you can see 2015 R1 as well as 2015 R2. And you can even go back and look at 2014 or some of the past releases if there's something that you want to recap on. So that's a great resource, and I'd recommend that you all go there for more information on the features that we've added today and more of the same in the future. And of course now I'd like to open the floor for any questions. So if you use the questions tab on the right hand side of your screen and type out any questions that you have, and we'll then read those out and answer them.
Right. Okay. Well, I think I'd like to at this point then say thank you very much to everyone for attending this webinar. I'd like to thank you. I'd like to say thanks to Michael as well. And thank you very much all for your time today.